Hello everyone, this is Jay from BTYT Tech Library. Today we are going to solve LeetCode problem number 48, rotate image. Actually, it's rotate square to the array. And I gotta say, it's one of the really confusing problem to me. The problem asks us to rotate to the array 90 degrees clockwise. For example 2, 5 goes to 11th position, 11 goes to 16th position, 16 goes to 15th position, and 15 goes to 5th position. There are many ways to solve this problem, but I think we can use swapping variables. With this strategy, let's rehearse the previous situation. First, let's think ourselves top left corner is pivot position. In example 2, its initial 5th position. So let's change the seats of 5 and 11. And then 11 and 16. And then 16 and 15. Now we can see that each vertex value of the 2D array rotated 90 degrees clockwise. We can apply this method to every position in the 2D array. Starting from our pivot position, we can move one step right for targets one step down. From the next vertex, we can move one step down for targets one step left. From the next vertex, we can move one step left for targets one step up. From the next vertex, we can move one step up for targets one step right. By applying same strategy from pivot position to right before the target position, we can achieve rotation of outer square sides. But how about inner squares? It's easy. We can apply same strategy but starting from different pivot position. Okay, then how many times? We can only do that the outer squares radius times, because that's the answer of how many nested squares exist. Now we have our strategy step by step. Let's code it up. Let's make a constant about the distance from the pivot to target position. And how many nested squares? Now it's switching position part. From the pivot position to each vertex, we only need 3 switching. Pivot to top right, in Kotlin, thanks to the scope function also, we don't need to temporary variable to swap two variables. Pivot to bottom right, pivot to bottom left. We apply the same way to other positions. Also inner squares. Let's run the code. When we encounter confusing problem, trying to build a strategy first by finding the pattern step by step and then express the strategy through the code is quite helpful. Like we did it before, from the vertex to the side and from the side to the square.